Okay, we are going to be adding and subtracting rational expressions today. And we'll be doing them with like denominators to start with, and then unlike denominators after that. And what's true about to be able to add and subtract fractions or rational expressions, you must have what? Chris? Okay, a common denominator, all right? So the first ones we're going to do already have a common denominator, but when you subtract, you've got to be very careful. So let's go ahead and do a couple of them then. Here we've got x minus 3 over the quantity x plus 4 plus x minus 2 over the quantity x plus 4. So when you're doing these, the first thing you want to do is if you've got a common denominator, then write the whole thing with that common denominator. So I'm going to put a fraction bar. Make sure when you're doing these that you always use a horizontal fraction bar. If that means you got to work on 2 lines all the time, work on 2 lines all the time. Okay? But don't do a diagonal fraction bar because you lose information doing that. And then I'm just going to rewrite this. Since it's a plus sign, if I do plus those things, that means that we're not going to have any sign changes, so I can just rewrite it. So here we get 2x minus 5 over x plus 4. Now they want us to identify any values for which the expression is undefined, so I have to look at my original problem denominators. Okay? So in both cases, they're x plus 4, and what would make x plus 4 equal to 0? Not x minus 4, but if x equals negative 4, then the denominator would be equal to 0. And since we can't divide by 0, then we would say that x cannot equal negative 4, because that's the spot where it's undefined, okay, where the denominator is equal to 0. And we, like I said, we go back to the original. When you're looking at that, you're going back here to the original problem to check that out. Yes, sir?
So our answer is for x cannot equal negative 4.
Yes, because it says identify where it's undefined. Okay. It's what would make the denominator equal to 0. Yes. Okay. Now the other thing is, we always want to check also, is it possible that I can simplify my answer? So is it possible that I could simplify this final answer here? And that would only be if I could factor the numerator and have x plus 4 as one of my factors. But with 2x minus 5, there's no way to get an x plus 4, so I'm done. That's my answer then. Okay, so let's look at one where we're subtracting. So 3x minus 4 over the quantity x plus 1, x squared plus 1, minus 6x plus 1 over the quantity x squared plus 1. Now I'm going to, as I do this problem, I'm going to add a step to it, and whether you add that step or not is going to be completely up to you. But like I said, the first thing I'm going to do now, I have a common denominator. I'm going to write a single fraction bar with that common denominator. Then in the numerator, we have our 3x minus 4. Now that's a positive there, but now I've got minus, so that means I'm subtracting this whole quantity. So I'm actually putting this line here as you do it, or that step there as you do it. If you want to put that step in there, it's up to you. You just have to make sure that with the minus that you use it correctly, okay? Because now when I do it, and I've got my same denominator. Now, what does it mean when I have a minus in front of a parenthesis? Okay, all the signs change. And so in this case, then, I'm going to have minus 6x minus 1. So what I'm telling you is that if you want to go from the original problem to the second step, that's fine, but you need to make sure that you distribute the negative to everything that's on the top of that fraction bar. Okay? Don't just make this negative 6 and leave the one that's positive. So a good idea would be to do this first step I did here if you don't want to, but you need go right to the second step. You got to make sure that you distribute the negative to everything. So now I can simplify it. So we have 3x minus 6x is a negative 3x, and negative 4 minus 1 is negative 5. All right. Now, we got to express when the denominator is equal to 0. So when is x squared plus 1 equal to 0? This is kind of a trick question. Okay. And the answer is it's never. Because x squared plus 1, the graph of that looks like this, where that's at positive 1. So it never crosses the x-axis, so it's never equal to 0. If I put 0 in here, we get 1. When I square a positive or a negative number, I'm always going to get a positive number, and any positive number plus 1 is never equal to 0. So this is never undefined. So that's my answer right there. All right, so make sure that when you're adding, just put the fraction bar, okay, and then go ahead and add them. But when you're subtracting, put them all under the common denominator, but make sure that if you don't use this first step here, that you distribute the negative all the way through it. Okay. All right, we're going to skip those. Okay, adding with a non-common denominator, or my denominators are unlike. And here, once again, they want us to identify any x values for which the expression is undefined. So first thing to do when you have unlike denominators is look at your denominators and see if either one or both of them can be factored. Because when we do common denominators, we want to look at whether I can factor them or not. So for instance, if I had 1/8 plus 1/6, can I factor 8? Okay. And can I factor 6 so that they have a common factor? Okay. Well, 8, I could write that as 2 times, so I've got 1 over 2 times 4, right? I could write 8 as 1 over 2 times 4, and I could write 1/6 as 1 over 2 times 3. So when I'm looking for a common denominator, well, both of these denominators already have a 2 in it, don't they? 1/8 and 1/6, they both have a 2 in it. But what does this denominator have that this one doesn't have? Okay. Has a 4, right? So that means then that I've got to multiply this fraction by 4 over 4. And then what does this denominator have that this one doesn't have? 3. So I have to multiply this fraction by 3 over 3. Okay. You all remember doing that, right? Or something similar to that. So now I've got 3 over, let's see, 8 times 3 is 24, right? 3 over 24 plus 4 over 24. There, I now have my common denominator of, so I can simplify it to 7 over 24. Okay. So you also have to do the same thing with when they're algebraic, okay? When they're just rational expressions instead of nice fractions with numbers that you don't like. Okay? So the first thing we need to do is we need to factor. So we'll factor x squared plus 3x minus 4. What do I get when I factor that? Okay, x plus 4 and x minus 1. So hopefully when I factor, I can have at least one of the denominators that are the same. So when I look at these denominators, okay, what does this denominator have, the one on the left, that the one on the right doesn't have? Okay, it doesn't have x minus 1. So then that means I have to multiply the one on the right by x minus 1 over x minus 1. Remember, I have to multiply by 1, okay, which is x minus 1 over x minus 1. And by multiplying by 1, I'm going to change the way it looks, but I'm not changing the value of it. Just like here. Okay, I changed the way 1/8 looked by multiplying it by 3 over 3, but in reality, it's now 3 over 24, but that's still 1/8, isn't it? Okay. So this is still 2x over x plus 4. I've just got this additional stuff. So my common denominator then is going to be x plus 4 times x minus 1. So on the left side, I have x minus 3 still. The fraction on the left. The fraction on the right, I have 2x times x minus 1. So I have 2x squared minus 2x. So now since I have a common denominator, I can simplify the numerator. See, there's a purpose for my doing some things. Okay? Take a break after writing the denominator so I can just keep copying and pasting and stuff, so I don't have to rewrite it. Don't you wish you could do that in your paper? Okay. So when I simplify this, remember when I simplify it, I want to write it in standard form too. So 2x squared, let's see, negative 2x positive x gives me a negative x minus 3. So now after I simplify it though, I need to make sure I can't go further with it. In other words, the numerator is a quadratic, and I have factors in the denominator, so is it possible that I have a like factor in the numerator that I have in the denominator? So we need to factor the numerator then. What do I get when I factor the numerator? Okay, remember that we have, this can only be 2x, and that can only be x. These two numbers can only be 1 and 3, but which one goes where? Which one's positive, which one's negative? Okay, Alyssa says 2x minus 3 and x plus 1. Does everybody agree with that? Because if we do the distributing then, here and here, this will give me a negative 3x, and a positive 2 gives me a negative 1. Okay, so that's the correct factorization. But even though I factored it correctly, these two are not the same, are they? Okay. So I can't do any further simplifying. So then I'll just leave my answer the way it was. So my final answer would be 2x squared minus x minus 3, and you can leave the denominator factored. And then in this case, x cannot equal, what makes the denominator equal here, or 0? Okay, negative 4 here and positive 1. All right, so 2x squared minus x minus 3 over the quantity x plus 4x minus 1, and x cannot equal negative 4 and 1. So after you factor, okay, factor the denominator, get the common denominator then, and work from there. Let's do another adding. All right. So can we factor either one of the denominators? X plus 2, can I factor that? No. How about x squared minus 4? Okay, that's the difference of two squares, and if I factor that, we get what? Okay. What do we get? Okay, so I can factor this one. I get x minus 2 and x plus 2. So I look at my two denominators. What does one have that the other one doesn't have? What's the one on the right have that the one on the left doesn't have? Okay. X minus 2. So we need to multiply the numerator and the denominator by x minus 2. Doesn't sound good out there for baseball, unless you're a duck. All right, so I have a common denominator now, x minus 2 and x plus 2. In the numerator, when I multiply x minus 2 times x, we get x squared minus 2x. And then we have a plus sign here, so then it's just plus negative 8 or minus 8. Okay. And then once again, we will factor the numerator to see if I might possibly have a common factor with the denominator. All right, so what do I get when I factor the numerator? What, Rachel? Okay. X minus 4 and x plus 2. Now that turns out real nice because I have a common factor then in the numerator and the denominator. So I can cancel both the x plus 2's. So I'm left with x minus 4 over x minus 2. We still need to tell where it's undefined. And remember that when you tell where it's undefined, you have to go back to the original. have to go back here. Okay? So I look at both of those denominators. Where or what numbers are going to make both those denominators equal to 0? Okay, -2 and +2, right? Okay, here we've got +2 makes this 0, -2 makes that one 0. Go back to the other side, -2 makes that one 0. So then x -2 minus 2 is -4. The factored part, yep. Okay. So plus or minus 2 would make it equal to 0. So this is your whole answer then. Okay, so when you're looking to see where it's undefined, go back to the original factored form to do that. All right, so finding the common denominator, factor the denominators. What one has and the other one doesn't have, then you need that. Okay. So let's look at subtracting. So 2x squared minus 30 over the quantity x squared minus 9 minus x plus 5 over the quantity x plus 3. Now when I said where the denominators are alike, you can, when I'm subtracting, I can either, you have a choice. You could write out the whole thing like I did here in the first step, or you can go right to the second step. It's not so easy to do that when when your denominators are not the same. So adding that other step in there is a really good idea. So first of all, we'll factor them. Okay, x squared minus 9 is x plus 3 times the quantity x minus 3. So we look at our two denominators. What's the one denominator have that the other one doesn't have? Okay, x minus 3. So that means I've got to multiply by x minus 3 over x minus 3. Well, this gets a little more complicated because you have to FOIL for 1 when you're multiplying that numerator, but you also have that minus sign to deal with. Okay? So this is my suggestion to you. Once again, write out your common denominator. First, put the one so the one on the left in this case I don't need to multiply, so I'll just write that one down. Now, minus parenthesis. You have to remember to subtract. So I'm going to subtract the whole quantity. I'm not going to subtract while I do the multiplication. So now I'll do this multiplication. All right, I'll go ahead and FOIL. So we get x squared minus 3x. 5 times x is 5x. 5 times -3 is -15. But I'm going to put that in parentheses. Unfortunately, this takes, if you write big, this takes quite a bit of paper sometimes. Now I can simplify it and distribute the negative. So we still have 2x squared minus 30. And now I'm going to distribute the negative. So my x squared becomes negative. What's negative 3x plus 5x? Okay, so when I connect those two x's, I have positive 2x, but when I distribute the negative, it makes it a negative 2x, and the negative 15 becomes a positive. And we'll simplify again. 2x squared minus x squared is just x squared. Then I have a negative 2x. And negative 30 plus 15 is negative 15. Once again, can we factor the numerator? So x minus 5 and x plus 3. So we do have a common factor again. So both the numerator and denominator have x plus 3. So we're left with x minus 5 over x minus 3. And then x cannot equal what? Can't equal 3, right? All right, but it also cannot equal negative 3, because if we go back to the original, if I put negative 3 in, I'd end up with 0 also. So x cannot equal plus or minus 3. What? 5's in the numerator. We don't care about the numerator. It's only the denominator. Because you can multiply by 0, right? I can have 0 for an answer, I just can't divide by 0. So it's okay that I'm not concerned about the numerator, only the denominator, where it's equal to 0. And in reality here, all right, with this first example, what does it mean if I have that stuff written that way? What's going on? Okay. Division's going on. That's all it is. It's a fraction. I have a fraction here, and then I have a different fraction down here. So if I have a fraction divided by a fraction, what are we supposed to do? What do we do then? You have a fraction divided by a fraction, what do we do? Okay, copy, change to multiplication, and flip it over. So we copy x plus 2 over x minus 1, change it to multiplication. We have x plus 5 over x minus 3. Now in this case, is there anything I can factor? No. Is there anything I can cancel then? No. So I'm just going to write my answer as the product of the factors. Numerator over the denominator. But when you see a problem like this, all it is a fraction divided by a fraction, copy, change, and flip, make it a multiplication problem, and you're good to go. Okay? Yep.